So, nanoscience and nanotechnology. Firstly, in scientific research, most of the scientists have a strong desire to see something extremely small. The advancement in current scientific researches with understanding certain structure at a tiny scale has enabled us to manipulate.
Kenapa tak buka presentation, buka macam ni? Nak edit tu kan?
So, among the studies on these tiny structures, there are those that relate to nanoparticles that have contributed to the rapid development of nanoscience and nanotechnology. So, the example of nanoparticles is graphene sheets and gold nanoparticles. So, my team members will explain more about graphene. So, what is meant by nanoscience and nanotechnology? Nanoscience is a study on processing of substances at nanoscale that are between 1 nanometer to 100 nanometers, while nanotechnology is a development of substances or gadgets using the properties of nanoparticles.
Alright, guys, awak kena faham beza antara nanoscience dan juga nanoteknologi dah. Nanoscience tu pasal sains dia. Nanotech tu nak guna je. Nak guna the aplikasi of science tu dalam nak buat apa-apa benda. Nah. Alright, terus.
So this is the size comparison between nanoscale and the materials around us. So basically in this subtopic, we will learn about the material that is sized between 10 to the power of -7 to the 10 to the power of -10, which is called nanoparticles.
Nah ya, kita nak fokus pada nanopartikel dah. Jadi nanoparticles ni yang mana? Yang bermula daripada mana kepada mana? Once again Najla, daripada mana ke mana?
So between 10 to the power of -7 to 10 to the power of -10 meter.
Okay.
Application of nanotechnology in our daily life.
Macam Syida hari ni ada ya.
Nanoparticle sizes from 1 to 100 nanometer produce various applications to be invented due to its extremely small in size. For example, in cosmetic field, the usage of nanoparticles is able to provide more satisfying outcomes as these extremely small particles able to penetrate the skin even more. Nanoparticles are also able to coat the surface more evenly, which makes them the best coating agent. Mind map on the next slide shows various other applications of nanotechnology.
Saya nak tengok mind map sebenarnya. Saya tak nak baca, saya tak tengok ayat-ayat. Macam ni okey lah. Nah. Kalau boleh kan, dekat textile, dekat agriculture, food tu, you put some pictures about that. Baru lebih menarik kita punya presentation lah. Okay. Tadi saya kumpul adik-adik memang menarik. Okay. Saya pujilah. I have to admit lah benda tu kan. Kalau salah, saya tegur lah. Yang ini saya tak puji, tak marah pun. Cuma saya bagi cadangan. Okay, to make our presentation more attractive, more easier to anybody understand our presentation. Okay, put some pictures. Memang dia akan tengok. Okay, so macam ni, dia dah menarik, ada colourful kat sini. But more attractive when you put a little bit picture, photo kat situ Right, okay. Teruskan.
These are the various applications of nanotechnology that had stated in the textbook. So let me give you some additional information to understand how nanotechnology can be applied in this industry. So let's move to another slide.
Menarik. Okay.
Sekejap, tak nampak. Okay. In agriculture industry, it helps to enhance the crop production and restoring and improving soil quality by transporting of genetic materials for crop development.
What is crop? Syida, what is the meaning of crop development tu?
Pertumbuhan tanaman. Okay.
Okay, boleh lah. Okay, teruskan.
In the medical industry, the materials with the nanoscale under 100 nanometer plays important role as the carriers for drug and gene delivery into tumors.
Itu contoh lah. Kalau orang tu sakit tumor ni kalau BM ke apa ketumbuhan
Ya.
ketumbuhan so dia penting untuk membawa apa-apa ubat ko gapo ko untuk pergi serang tumor tadi tu alright terus.
In the semiconductors and electronics industry, the driven water flow in nanoporous carbon film converts ambient thermal energy into electricity.
Apa dia ambient thermal energy tu?
Haba di sekeliling nanoporous carbon film tu.
Okay, good. Ambient tu maksudnya yang ada dekat dengan dia lah. Yang ada sekali dengan dia tu dah. Alright, terus.
In the food industry, enzymes are often added to food as to increase bioavailability of essential nutrients and also to detect bacteria in the packagings.
Okay.
Last slide. Okay, for the textiles industry, the surface of textiles are coated with nanoparticle that will produce a highly active surfaces to have UV blocking, antimicrobial, wrinkle resistant, and also water and oil repellent. And lastly, the energy and electric.
Sekejap, Syida. What does it mean of water repellent tu?
Ya Allah, resistant gitu.
Macam dengan kalis air ke apa?
Kalis air.
Hmm.
Hadang dari air.
Okay lah. Tapi dia tak adalah kalis terusnya ke? Okay, terus. Okay.
And lastly, energy and electricity industry. It is to reduce the cost of catalysts used in fuel cells and improve the efficiency of membrane used in fuel cell to separate hydrogen ions from other gases.
Okay, good.
Okay.
Walaupun ini nano ni benda baru, okay, but the development dalam benda ni sangat-sangat rancak sekarang. Means kalau pergi kat universiti, okay, you terlibat dengan nanotech punya teknologi, nanotech punya kajian, memang awak adalah orang yang advance dah. Advance. Bercakap pasal membrane, pasal nano ni, awak orang advance dah. Okay, terus.
Okay. So now let us move on to the development in the field of nanotechnology. Okay, next slide. So the coverage of the field of nanotechnology is very wide, including physics, chemistry, biology, medicine, and engineering. So this contributes to the rapid research and development on applications of nanotechnology in various aspects of life. As an example, a material that has become one of the main focuses in the nanotechnology is a carbon derivative that is known as graphene. Graphene is one of the carbon allotropes other than diamond and graphite. The size ranges from 0.1 nanometers to less than 20 nanometers. Graphene can be converted into other materials such as graphites, carbon nanotubes, and fullerene balls.
Okay, ni yang terbaru Biasanya kalau kita sebut pasal karbon ini, dia ada diamond, okay, dengan grafit. Tapi sekarang ni bila dalam teknologi nanotech ni ada graphene pula yang biasa tu yang graphite tu dengan diamond tu biasa. Okay, terus.
Okay, so these are the examples that we can do with the graphene. Graphite, diamond, BC8, fullerene ball, nanotube. That. Okay, next slide. Now to the physical properties of graphene.
Okay.
Graphene has many physical properties such as strong and hard, elastic, transparent, impermeable, good conductor of heat and electricity, and very low electrical resistance.
Okay, so we proceed to the chemical properties of graphene. Next slide. Graphene sheets burn at lower temperature than graphite. Graphene is the most reactive carbon allotropes. Researchers are still studying in detail the chemical reaction of the graphene due to the relatively new discovery and isolation of graphene. A few compounds have been successfully been synthesized, namely graphene oxide that is used as a catalyst. Okay, we go to the uses of graphene. First, electronics. The arrangement of atoms in graphene enable it to be a superior conductor. Graphene can be used as a coating to improve current touchscreens for phones and tablets. It can also be used to make the circuitry of our computers, making them incredibly fast. There are just two examples of how graphene can enhance today's devices. Next, sensors. Graphene has high surface area. Then, graphene is an ideal material for sensors. Every atom in graphene is exposed to its environment, allowing it to sense changes in its surroundings. After that, biomedical. Sensors, tissue engineering, medical delivery system. Graphene's unique property allow for groundbreaking biomedical application. Targeted drug delivery, improved brain penetration, DIY health testing kit, and smart implants. Next, polymers and composite. High mechanical strength makes graphene suitable for polymer composite materials. Next is membrane. Membrane is for water filtration. Separating water from gaseous mixtures, graphene oxide membranes are capable of forming a perfect barrier when dealing with liquids and gases. They can effectively separate organic solvent from water and remove water from gas mixture to an exceptional level. They have even been proved to stop helium, the hardest gas to block. And last one is energy. Batteries that last longer, flexible and strong. Besides, it is supercapacitor. Graphene supercapacitor could provide massive amount of power while using much less energy than conventional devices. Because they are light, they could also reduce the weight of cars or planes. Imagine fully charging a smartphone in seconds or an electric car in minutes. That's the power of graphene. I think that's all from us. Thank you.
Okay.